Hello guys, Enchanted Goose here with another build video. Now, today we will take a look at the ZVS oscillator. However, this one comes with a quirk. It has a triple output. Sometimes you come across this kind of transformers that have, besides their output, a feedback wire. So that means they have 3 input wires and 2 output wires. That is true for this AC flyback. I wind it myself as well. And a feedback wire is essentially, as you can see, the ends of the 2 loops of wire connected together in a simple one wire that goes to the center of the clamp, and the other goes to the right and the left side of the clamp, and we'll see how that goes. It works, and the output of course is 2 wires. So let's take a look at the schematic. We have 2 MOSFETs over here and over here. I've used the, didn't even write it down, the IRFP 260 and MOSFETs for this build. So what's going on is one of those MOSFETs, due to nothing being identical, switches on first and then it turns off. The other MOSFET turns on, and that's how power is starting to switch. And then we have, as you can see, a center tap transformer that I've connected here in order to complete the circuit, because if you do not add the center tap transformer over here, the circuit does not self-oscillate. It's not that. It's not like the two inductor ZVS circuit that is self-resonant on its own. These feedback windings actually play the role of the second inductor that we add in the 2 inductor ZV8 circuits. So, and then you can connect your secondary winding and get high voltage. Next is simple. You get Zener diodes from the source to gate, and from the source to gate 10 kilo ohm resistors in order to protect the Zener diodes. Each base gets a 220 ohm resistance. VCC is 12 to 30 volts pushing it. These Zener diodes are 15 volts 1.3 watts, and the inductor can be anywhere from 40 to 250 millihenry, microhenry, rated at 10 amps. So let's see. Here are all of our components. So let me punch some holes into this beautiful circuit board to get our MOSFETs in, and then we will continue. So, after a vicious battle with the circuit board, I managed to punch through and get my MOSFETs in the circuit board. Now we will start adding the rest of the components. See you in a bit. Also, as you can see, I bent the source and gate leads of each MOSFET down and place the drain pins to the front side. That's in order to help me add the rest of the components easier. So now we will add these two 15-volt Zener diodes across the source and the gate of each MOSFET. So as you can see over here, the Zener diodes are added from the source to the gate, and now we will solder them. Soldered and ready to add the 10 kilo ohm resistors. So there are the resistors added, and now what we have to do is solder them as well and connect them with the Zener diodes and with the gate and source of each MOSFET. And this is what it should look like. We've soldered the Zener diodes, the 10 kilo ohm resistors across the source and gate of the MOSFETs, and now let's add the diodes. And these are the diodes we'll be using. As you can see, they are ultra fast diodes. I think the recovery time is something like 15 nanoseconds. So I'll go ahead and add this, and then I'll show you the direction that we add those diodes, because that is really important. So we add the diodes, and as you can see, this diode, the first diode, the one on the back side, goes from the gate of this MOSFET to the drain of this MOSFET, and this diode, the second one, goes from the gate of this MOSFET to the drain of this MOSFET. Now let me solder it. Now let's add the two 220 ohms gate resistances and our toroid. So we added the gate resistances and our toroid. So its resistance is connected here, and the toroid is also gonna be connected here. This is the resistor divider, and then the resistances feed directly into the base, into the gate, transistor logic, into the gate of each MOSFET. As you can see, one feeds in here and the other one feeds over here. So let's solder and proceed. So guys, now we've soldered the resistor divider, and we've also soldered the one side of our inductor, our toroid. Now let's add the output clamp, and the clamp is added and soldered, as you can see. Now I'm gonna connect this other side of the wire of the toroid in the middle pin of the clamp. And that's done. Now let's add our capacitor. As you can see, we added the capacitor and it barely fit into the circuit board. Lucky me, I guess. So now what we need to do is, these are the capacitor legs over here. What we need to do is connect the drains of both of the MOSFETs to the capacitor's pins. So let me do that and I'll be right back. And as you can see, we have connected both of the drains of the MOSFETs to the ends of the capacitor. I used a piece of jumper wire here because I didn't want it to short out with this wire, because I've actually taken the enamel off in order to solder it. So that's why I used the jumper wire instead of solder in this side. Now the rest of the output is connecting the end of this capacitor to this pin and the side of this capacitor to this pin. So let's do this and then let's go to the output. So guys, we've connected both ends of our capacitor to the ends of the three-sided clamp. One is from this capacitor that feeds from this drain. The other side is from this side of the capacitor that feeds from this drain, and the middle one is where the power inductor is that connects to our resistor divider. And now let's do the input. The input is really simple. We need to join those two sources, this pin and this pin, and let me do this and I'll be right back. And as you can see now, both of the sources of the MOSFET are connected with this jumper wire. And let's add the clamp. And as you can see, we've added the clamp that we will connect to the voltage power supply. This wire feeds directly into the MOSFET sources. This wire feeds into the resistor divider through the inductor, and here we'll connect our transformer. So let's see how things go. So let's see. Let's go to, I don't know, 14 volts. And let's try and draw an arc. Holy shit. How? Shit. And after that pretty demonstration, let's try a CRT flyback with a feedback winding. Let me turn up the power slowly. The voltage actually, I've adjusted the amp knob to the maximum, so I only turn up the voltage to this point. Let's see. I hear the high voltage, but let me bring the leads closer. Well guys, this flyback transformer didn't wanna play nice with me. So yeah, it kind of killed one of my MOSFETs. So it's kind of a dramatic ending. I'll replace it. Anyways, so that was the one Inductor ZVS system. Thank you for watching. Please like, comment, share, and subscribe if you haven't, because I'm gonna be releasing a lot more content soon. I have lots of ideas to cover, and yeah, thank you for watching. Until next time, and Chatting Goose signing out. Thank you.